Okay, I think you'll find section 3 very doable. The worst part is what it's called. Okay, so differentiability is the word that means, are we able to find the differential? And differential is the other word that is used for derivative. I don't know why they have multiple words that mean the same thing. But essentially, differentiability is the common term for, are you able to take the derivative? And so you guys will get questions where you look at a graph like that or something. Maybe even an equation, but usually a graph. And it'll say, where is this function differentiable? So it basically means, where are you able to find slope answers on that picture? Now, if you have your Chromebook open and you want to use it, you can type in that bit.ly up there, and it has an interactive version of this graph. I'm gonna put it up on the screen, so if you don't wanna go to it yourself, it's not a big deal in any which way. But a lot of these questions go from this picture, and essentially the only difference is there is a moving tangent line and the graph of the derivative. So it's not terribly needed. So let's start. I already forgot who we decided to start with. That's right, Charlie.
Yeah.
That's right.
Yeah.
That was the good move, yep.
Yeah.
Okay. You want to answer this one, or do you want somebody else to answer it?
Someone else can answer.
I see. I assume so, since that was your goal. Okay, who's gonna answer this one?
20.
Is it Alex?
Yeah.
Oh, okay. So Alex, essentially question number 1 is, where is this graph not continuous?
From -4 to like -5.
Wait, what?
Were you asking like where it's not continuous at? Oh.
Oh, actually, now that you say that, it does kind of look like there's an arrow, like, going from that point. It's not supposed to be connected, though. So, this little section right here is where the graph ends.
Yeah. That's what I meant. I couldn't see the numbers correctly. So.
It's on your paper.
Oh. Okay.
Okay, so where is it not continuous?
From like -2 to -4.
Nope.
Oh, just -2.
Correct. So you were basically answering to me where it is continuous. You were reading off the section. So where it's not continuous is almost always individual numbers. So -2.
And then 2 as well.
Anywhere else?
-4.
Oh, got you. We won't count that one because we were only looking in between -4 and 11.
Okay, so then.
So -4 probably could have been considered that otherwise. But correct, so those are the only 2 spots. Okay, so I think most of you have continuity down pretty good by now. Just where something is continuous. That's actually a big part of, can you take this slope? Okay, so automatically right away, if something is not continuous, it can't have a slope at that spot where it's not continuous. Okay, there's gonna be other criteria, but that's the main one. The main one is if a graph or a function isn't continuous, automatically no slope. Okay, good, Alex. Who's gonna help me from there? So that's good. Well, that's number one.
19?
Just say the person if you,
Arju?
okay?
Number 2.
Yeah, so I don't know if you, I know what the question is trying to ask. But- Actually easier than that, but you're correct. So it's basically asking you, are they positive slopes or negative slopes? They frequently will ask you if it's increasing or decreasing. So we haven't had a question like that yet, so so what are the slopes doing from 7 to 9?
Is it increasing?
It is not. I don't know if you're looking at a different spot.
7 to 9, oh, shoot.
Okay.
It's decreasing.
Okay, good. So it's decreasing. Decreasing is a term for negative slopes. You don't care how the negative slopes compare to each other. You just care that they are negative, so the graph is going downwards. Now, for your own benefit, you most definitely want to put like these things I'm putting in parentheses, because that's essentially like explaining it to yourself. Like getting good at writing notes to yourself is very helpful. You probably didn't need it on number 1, just because that's fairly straightforward. Okay, I don't know if we need to do that for the next question or not. Arjun,
G.
okay,
Oh, increasing?
correct. And I don't know if we need to talk about this, but it's going upwards, it's going downwards. Increasing and decreasing actually is going to be a big part of derivatives. We're going to learn something called the first derivative test in a little while, and there are many things to look at. Increasing and decreasing actually guide you to a bunch of them. So that's why we're starting the terminology now. And even if it seems super obvious to you. Okay, next person who has actually sort of a tough question.
30?
Elise? How would you describe the slope at 9?
There's no slope.
Okay, perfect. I don't think we've talked about that, have we? Okay, if there is a sharp point, there will be no slope. Slope can only happen when it's a continuous, smooth curve. Sharp points have no slope. Now, if you want the mathematical information, the limit of the derivative to the left, the limit of the derivative from the right are different. So the limits on both sides have to be the same for it to have slope. So I'm not sure. I thought I would try to be better about writing the more mathematical versions, because like say on that last test, to be continuous, you have to show that the limit from the left, the limit from the right, and the function value are all the same. But a lot of people didn't put that, and I think that's because I didn't emphasize it enough. So I want to emphasize the real math terms more. So the limit as x approaches 9 from the left of f prime of x is not equal to the limit as x approaches 9 from the right of f prime of x. So the slope on the left, the slope on the right are different. And when I say left and right, like immediately to the left and right. So a sharp point would obviously have totally different slopes on both sides. So you can't have a slope on a sharp point. It's not a difficult concept to figure out, but it's just there are so many details. Anybody think they can tell me 5? I don't wanna call on somebody for this one. I didn't know if this felt like a big ask. Would you guys be able to write out the equation of a tangent line without knowing a function and a value? How do we write a point if we don't know the point? So, in previous classes, we used to call them x1 and y1, or just x and y. But in calc, we generally refer to it as a f of a, and then b f of b. So I could write the equation of a tangent line without knowing any info. So we're going to do this right to the left of 1. Okay, now point slope form, which quite a few people asked me about when we were doing it, I think it was 2.1. So we're going to have y minus, what two numbers should we use right before x equals 1? We'll just pick any two. Should we do like 0.98, 0.99? Sounds good. Okay, so I'm going to do y minus f of 0.99. So this is like y minus y1. The slope would be f of 0.99 minus f of 0.98 over 0.99 minus 0.98, which would be 0.01. X minus 0.99. So that would give me the tangent line. Even if I don't know the graph, I could type those in to figure it out. You'll get much more used to tangent line equations because we use them a lot throughout the whole year. And I feel like we can skip 6. Or maybe what I should say is, why don't you guys try to write the one for 6 on your own? Oh, and it didn't matter if I chose 0.99 or 0.98, because you can pick each point. It still would turn out correct. What I want to see right below that is when I have to start using decimals. So our goal for today is just to do this one page. I mean, if we can get all of it done, sure, but I just don't think we will. Did you answer those?
Yeah.
Excellent. Who's going? 20. You guys could just say the person if you know who you're calling on.
Abe.
I see. Abe, what would be the slope at 1 and or why is, you probably already know the answer and reason.
The slope at 1?
The slope at 1.
Do I have to solve for it?
Definitely not. Unless you're looking at the wrong spot. What was the slope at, I think it was 7? 9. What was the slope at 9?
No slope.
Because sharp point. So 1. I think you're looking at the wrong spot.
Oh, I was looking at 0.
Yeah, okay.
No slope.
No slope because
It's
sharp point. Good. Yeah, I assumed you had been looking at the wrong spot there. Okay. Now, I'll open up the graph. And this is pretty much exactly what Luke taught me last week. Is we've got a tangent line that can be moved. So if you want to open this on your own, go for it. But I already set up so that it would be right by this sharp point. So tangent lines show the slope, and we can tell that right on the left, I don't know, slope is like 5 or something. Right on the right of 1, it immediately switches to -2. And we can't just average the numbers. So if you have a sharp point, no matter how much I try to put the cursor right on 1, it's not going to show anything. In fact, if I move the cursor to this hole, the tangent line completely disappears because there's no slope at a hole. If it's not continuous, no slope. If there's a sharp point, no slope. That's pretty much what we're trying to get out of this. A function is going to be differentiable as long as it is continuous and no. Oh, how should I phrase that? I phrased that horribly. Oh, I don't want to erase the site, the schedule. Does anybody know how a sharp point would show up in the derivative equation? So we're going to have equations that won't be differentiable everywhere. How does something that is not continuous show up in an equation? It's like an x value that can't be used.
Yep.
Okay, so holes, asymptotes. Something won't be differentiable if the derivative has x values that can't be used. So if your derivative has a denominator with that x can't be 0, x can't be some sort of a number, continuity and differentiability are the exact same things in different equations. So if a regular function is continuous, there would be no x values that can't be used. If a derivative is continuous, that would mean there's no x values that can't be used, so it would be differentiable for every x value that you can plug in. Oh, wait, we're not done with that page yet, are we? Oh, 10 is the one I wanted to go to. I can't remember which question we had. Was it on that quiz, horizontal tangent line? You guys had a question about a horizontal tangent line. Maybe it was the homework. Abe, I need somebody.
Drew.
Drew. Where would this graph have a horizontal tangent line? And or what are you looking for?
Where it would turn around on the parabola.
Oh, sure. Wherever there's a slope of 0.
Yeah.
Yep. So that pretty much exclusively happens when the graph turns around. Okay, where does this graph have slope of 0?
-1 and 5.
-1, 5.
And then that flat line before it.
Oh, actually, I was ignoring that part too. You're right. That is 100% correct. So -1 and 5 are going to be the parts that we normally search for. A slope of 0 is going to be frequently where your graph turns around. And so that's going to be an important thing that we look for, which is number 11. On your packet, I wanted you guys to try to draw the derivative. Make a rough sketch of the derivative. So we've done that a couple times in the last couple sections. but directly on your packet, why don't you try to draw the derivative right on the same graph? And then I'll show you the answer here in a second, and then I think we get done at 57. Yes, 57. Okay, so after you get done drawing the derivative, I'll kind of leave it up to you guys. I have a section that you need to copy down, / if you want to start your homework today, you can, but we'll finish the notes tomorrow. And then have I even talked about Wednesday in here? So I would say probably 2/3 of this class is taking a test on Wednesday. Yeah, because it would be only seniors that aren't, right? Who in here is seniors? Okay. Is. So on Wednesday, you have to take attendance. I theoretically have to give you homework, but your homework is to finish anything from Tuesday. The homework for 2.4, 2.3 is due Wednesday night. I wanted you guys to have it due before your days off started, because otherwise too many people will put it off till Sunday night. So homework actually goes pretty quick in this section. So I had it due Wednesday night. And we'll get time to work on it in class tomorrow too. Okay, let me draw, this is why on Desmos, if you wanted to open it up on your own, because the first graph was labeled as f of x, I can just have it draw the derivative. Let's pick a better color. Does that purple show up okay? I forget how you change colors. Oh, this, yeah. I don't know if that's better. So from here to here, it has a slope of 0. Apparently, we start off with a slope of -4, and at the top of this, it has a slope of 8. So this line right here, you guys may have a completely different line, as long as your line crosses at -1. It has to cross at -1 because that's where there was a slope of 0. So your line may not go down as far, depending on what you estimated the slope to be. Your line may not go all the way up to 8 because you might have estimated this to be less than 8. But your line has to cross at -1. And then the next piece of line has to cross at 5. Theoretically, you should have a hole in your derivative at 2. This one does not. And then they were easy to figure out slopes because they were straight lines. I think this is the first one you guys have had to draw slopes on a curve. Do you want me to show you how to make this line? Were you guys, okay, I'll open up the notes then. So when you are doing curves, you're essentially just going to be estimating. And your estimate doesn't have to be exact at all. Even on the AP test, they would give you a margin of error. So on a curve, you specifically pick the spots that you know exactly what they are. So like this one, I know is a slope of 0, so for sure it has to cross right there. Now the curved part, I can guess. Like I would have guessed this is a slope of -2 or -3. So I probably would have put it like right there. Apparently the real answer was -4. I would have guessed right about here. Oops. I would have guessed right about here is about a slope of 2. So I would have put a height of 2 right there. And then up at the top, I probably would have only guessed like 4. Even though it was apparently 8. And so I would just have to make a smooth line out of this, out of my guess. Making sure it crosses at -1. This curve is probably a little bit easier because it's flatter, so your guesses would be better. I do know that it has to cross at 5. I know that this, I probably would guess that that's a slope of about a half. That looks like about a slope of 1. Right here looks like a slope of about a -1/2, -1. Right there looks maybe -2. And then we know it's gonna be a line, so I would just make it a line. You're just gonna estimate using the info that you know to make it better. So here's the part where I didn't know if you wanted to do today or tomorrow. I didn't know if you wanted to copy this down before you started the homework. It basically kind of already says what I talked about. At locations where it's not continuous or sharp points, there's no slope. Actually, this is probably the first one where this box kind of we've already covered it. But this has the rest of the details that I might have forgot to say out loud. Now, I wanted to do the check your understanding together tomorrow, but we've already learned, technically we've learned the whole section. So if you guys want to get the homework done right away, feel free to get going. I'm sure some of you are just putting it off until you do the retake though. Like, I have a feeling some of you are just studying for the retake tonight rather than homework. In that case, you could get the homework done tomorrow night. Have they sent emails home to you guys about which test you're taking on Wednesday? I mean, I heard very little about it until last week. So sophomores have pre-ACT, juniors have practice ACT. I think they are also giving the PSAT, but I was gonna say, they didn't tell us anything about that, so I'm assuming they proctors or other people or something. Cause all the teachers are proctoring the pre-ACT and practice ACT. But just to emphasize, they're not necessarily something you need to study for. The point of the practice ACT is so that you can see what types of questions are on the real ACT. If you wanna study for it, you can, but I wouldn't put a ton of time into it. PSAT is the same thing where it's a practice SAT. Okay, we have 7 minutes left today. If anybody wants to turn in work to me or ask me questions oh, I forgot to ask if you guys had any questions, didn't I? No, I did that Friday. Did I give you guys a chance to ask questions on 2.2? can't remember.
No.
I feel like I did Friday, but I don't know. Like, if you guys need help with anything from the homework, feel free to ask. Even if I forget to do it in class, you can ask and I'll take a break and do it then. But with these 7 minutes now, if you have a question from homework, that'd be a good time for me to answer it.